everybody, I'm here to help you get ready for tomorrow's quiz. I know that some of you are having trouble, so what I decided to do is go ahead and go over this review with you now. That way if you have any questions, you can check this out, and if not, you can come see me tomorrow morning for help right before. Okay, so first off, let's go ahead and get started with this first problem here. In problems 1 through 8, what we are trying to do is we're trying to simplify using our properties of exponents. So what you should get out is your graphic organizer that we discussed last week. Alright, in this problem, I want to reorder and reorganize this, okay? So what I'm going to do is I'm actually going to multiply 2 times 2 times 2. Because I have 1, 2 here, here, and here. Then I want to multiply k times k to the negative 4th times k to the negative 2. Now what this means is that I have now grouped my like terms here and here. So 2 times 2 times 2 is 8, and k times k to the negative 4th times k to the negative 2. Now remember, there's a 1 here, right? So what we're going to do is we add, this is negative 6 plus 1 to the negative 5. Now the problem is we are not allowed to have negative exponents. Remember, directions say only positive exponents. This direction will also apply for your quiz tomorrow. So what I need you to do is I need you to make this equal to 8 over k to the 5th. Now the reason that the k to the 5th is the only one that goes to the bottom is because k to the 5th is the only one that has a negative exponent. That 8 will also have a positive 1 on here. Alright, moving on to another problem. In this problem right here, we need to distribute the 4 to both the 3 and the b squared. Many of you will make your mistakes when it comes to this. You will forget that the 3 is in the parentheses, and we'll also need the 3 to the 4th power. Okay, so we have 3 to the 4th, and then b, we're going to multiply these to the 8th power. Now we're going to simplify 3 to the 4th as 81, and we have 81 b to the 8th as our final answer. Okay? Alright, moving on. Let's go ahead and work on number 6. Okay, first off, you need to break this up into like terms. I have 2/3 times r to the 3rd over r to the negative 2. Now, 2/3 is something that I would type in my calculator and see, can I simplify this? Which it cannot, so I go ahead and I write a 2 over 3 in my main answer fraction. Okay, now I need to solve my r's. When I divide, I need to subtract my exponents. So r to the 3 minus a negative 2. Now some of you may have put r to the 1. You have to be careful. R to the 3 minus a negative 2 is actually adding. So we have r to the 5th. Because it's positive, it stays up on top, and that is my answer. Okay, let's go ahead and work on number 8. First thing I want you to do is get rid of these parentheses. So I need to multiply these exponents. Okay, this comes from your graphic organizer. So I have n to the negative 9 times n squared. Now when I multiply like bases, I need to add my exponents, okay? So we have n to the negative 7. Oh, but there's a problem. I'm not allowed to have negative 7. I'm not allowed to have negative exponents at all. So what you need to do is move this in to the bottom of a fraction and make it positive now. Because there's nothing on top, we go ahead and write a 1 to kind of hold the place. So the answer to number 8 is 1 over n to the 7th. Okay? Alright, I'm going to pause here, let you take a look, and then I will scroll down and work on some other problems. Okay, I'm going to go ahead and clear this. Feel free to pause at any point of this if you need to write down some things. Okay, let's go ahead and take a look at number 9. I would first off, 2x is what we call the radicand. So I would go ahead and write 2x in parentheses. Now I need to take this to a fractional power. So what I'm going to do is it's going to be 3 over 5 as my exponent. Now the reason I know 5 is in the bottom is because 5 is inside the root symbol. 3 on the outside will be up top. Okay, so let's do another example. Let's do number 11, okay? Again, write the radicand, what's underneath that square root sign, in parentheses. Now we know the 3 goes on the top, but okay, some of you are saying, uh-oh, there's no number here. Remember that this is called a square root, so there's actually an understood 2 there. So this would be 2b in parentheses to the 3/2 power. Alright, moving on, let's do some of these. This is actually doing the opposite of what we did here. Okay, so what we're going to do is we take 6v and we put it under a square root symbol. What we then have to do is write this number here and raise it to the power of 5. However, we're not required to write the 2 here because square root automatically means 2 unless you put another number there. Alright, so taking a look at number 15, same thing, I do 10x, put it under the square root, okay, 5 goes here, and then I raise it to the power of 6. Alright, now when we add polynomials, okay, we need to add like terms. So let's take a look at number 19. I have a 2x to the 4th and an x to the 4th. I'm going to add those, and I'm going to get 3x to the 4th. Now I also see that I have a 5x squared. Okay, 5x squared, there's no other x squared term here. So I simply write 5x squared all by its lonesome on the bottom. Alright, and then I see I have a 6x and a 7x. So when I add those, I get a 13x. And that is how you would add these two polynomials. Okay, I'm going to pause here for a second. Feel free to write down some of these. Alright, again, feel free to pause the video at any time to write down what you need. Alright, now with subtraction, it's very similar to addition, but what we need to do is we need to change this to an addition problem. So what we're going to do is we're going to distribute the negative to both terms inside the one following it. So I simply rewrite the first polynomial, and now I am adding negative 4r and negative 2r to the 4th. So when I add like terms, I get 7r to the 4th minus 2r to the 4th is 5r to the 4th. And 6r minus 4r is 2r. Okay? Now, be careful on problems like this when you distribute the negative. Make sure you distribute it to every term. Oops. Okay, so this actually becomes a plus 5x, or excuse me, plus a negative 5x minus 3x cubed plus 8. Okay? So the negative becomes a positive, and all positive numbers become negative. Okay? Moving on to multiplying. Okay, just remember if you have a single term out here, you are going to multiply to every single term. So 3v to the 4th is the same as 6v to the 6th. Okay, as a side note here, remember v to the 4th times v squared, we add our exponents and we get v to the 6th. Okay? So 6v to the 6th, and then negative v times 3v to the 4th is negative 3v to the 5th. Remember, there's a 1 on this v right here. And then negative 7 times 3v to the 4th is negative 21v to the 4th. On number 28, what we have here is a FOIL problem, or in my case, I would like to use the box method. So I do 3n plus 5, 5n plus 1. So I get 15n in this box, squared, 25n, 3n, and 5. I'm sorry, this is a little small here, but I'll write it bigger. So I have 15n squared. Now I have to add 3n and 25n, so I get 28n, and then I add the 5 to the end there. So we combined our like terms to get the 28n. I'm going to pause here and allow you to write down what you need to write down. Okay, again, feel free to pause the video as you need. Alright, and last but not least, we are talking about rational and irrational numbers. Remember that irrational numbers are never end, okay? Do you remember that song I showed you? Lamb chop, this is the song that doesn't end. Okay, if it doesn't end, it's irrational. Okay, if it doesn't repeat, it's irrational. Okay, so what we have right here is a number 0.24, and 0.24 ends, so this is going to be a rational number. Now what I would expect in your reasoning is that you would say 0.24 ends and can be written as 24 over 100. I know it's 100 because I'm going to move the decimal place 2 times. Okay, 7/4 is rational because it's written as a fraction. Okay, so we write it as a fraction. Anything that can be written as a fraction is called rational. Now we have 1.2453 ... This ... is key here. When you see ... you should write irrational. Okay, it's because the number does not end. And last but not least, square root of 3 over 2. Square root of 3 is an irrational number, so this makes the whole number irrational. My reasoning is because square root of 3 is irrational. Okay? Now when we talk about things being closed under addition, remember that we're supposed to add everything in here. And if we get a number that's not inside the set, then it's not closed. So for example, if I add 1 plus 2, I get 3. Do you see that 3 is not inside this set? Therefore, it is not closed. And I would simply say not closed because 3 is not in the set. And on number 34, what we're doing here is 0, 1, 2. This time we're doing multiplication. So what I want to do is that you're looking here is that you multiply 1 and 2 together, you get 2. However, don't forget to multiply 2 times 2, and you will actually get 4. Notice again the same reasoning here. 4 is not in the set, therefore it's not closed under multiplication. Now some of you were confused about rational numbers. Okay, remember rational numbers, if I add 2 plus 5, I get 7. This is rational plus rational equals rational. This will always be closed. The reasoning for this is because a rational plus a rational is always going to be rational. Okay? And then our very last problem, it says the set of irrational numbers is closed under multiplication. Okay, I can provide a counter example for this. Here are 2 irrational numbers that when I multiply them together, I get 1. However, 1 is not irrational, it is rational. So the answer to this one is not closed. Okay, I hope that helps. If you have any questions, see me tomorrow morning.